This is part 2 of the intro to the derivative. This is finding the derivative, and this is page 2 of your notes. So to summarize what we talked about in the first part, the derivative is the instantaneous rate of change at a particular point on the graph. Or we could say the instantaneous velocity if we're talking about distance over time, but this could refer to any kind of rate of change. Secondly, the derivative is the slope of the tangent line to the curve at that point. And recall, a tangent line just touches the graph at one point, so we can't find slope using 2 points with a tangent line because a tangent line only touches the curve at one point, so we don't know what its another point for that tangent line. So this is what we're going to talk about today. How do we actually find the slope of that tangent line exactly? We can draw what looks like a tangent line and estimate the slope, which is what we did before, but we want to find it more precisely. So I want to open up something on the internet. It's a little applet to show you. Let me find where I have that. Oh, it's actually not on here. It's on this one. Okay. This is a picture of the bird in flight graph, and that's the black curve. The red line is the tangent line to the curve at that point. And this green line represents what we're going to do to estimate the slope of that tangent line. So imagine if I wanted to estimate the red line, the slope of the red line, I could pick 2 points that were really close together on the curve and get that line really close to the red line. So that's what I'm going to do, is I'm going to pick a point that's really close to the point of tangency, really close to 220, and I am going to estimate the slope of the tangent line by doing that. So that's what we're going to start out doing. So here's what I've got this drawing, is I'm going to estimate, I've got my point 220, and I've got another point labeled x f of x. And the reason it's only labeled x f of x is I'm going to change and put in different values for x and calculate different values for y for that point. But we're going to imagine what happens is that point, that x f of x, gets closer and closer to the point 220. The closer and closer that point gets, the closer that my line here that goes through those 2 points will be to the tangent line, if the 2 points on my line are really close together. So let's start out by letting x equal 2.1, because 2.1 is really close to 2. And then I want to calculate what f of x equals for 2.1. So what you're going to want to do is get out your calculator, and I would suggest typing in 2.1, storing it for x, and then just typing in this function. So I'm going to pause a moment on my video and open up my calculator and let you do the same, and let's calculate what f of x is for this particular value of x. I'm going to take you to what I did on my calculator. On my calculator, I put in this function on my graph, in a graph, and this is going to save me time later on. This is why I'm doing this. And I made my window settings. I changed my y max to 35 and my y min to -5 to match what's on the picture on my notes. Now I left my a little bit bigger x's and x min and x max just because if I made them exactly like what was on the paper, it kind of made my graph look sort of deformed and stretched out. But anyway, this is what the graph that I'm looking at. And the reason this saves me time is when I go back to a calculator page, this is my equation f1 of x. Now you, depending on what document you might have used, maybe yours might not be f1. You'll want to check on that. But then you can just type in f1 of 2.1 and it'll tell me what the y value is. So I found the y value, and then I did the slope. 21.131 minus 20 over 2.1 minus 2 gives me 11.31. So I'm going to grab this, and actually I'm just going to write this down on my paper here. So this is 21.131, and when I do the slope is going to be remember, this will always be my x1 and my y1, the 220. And the other point is always going to be my x2, y2. So whatever I get for my x f of x point is going to be my y2. So this is going to be 21.131 minus 20 all over 2.1 minus 2. And this gives me 11.131. So this is telling me, so far I've estimated the slope to be about 11.131, which is pretty close to what I had before of 10, but I know my 10 is not accurate. It was just an estimate. Now I'm going to say let x equal 2.01, and let's find out what f of x is. And then let's do the same thing when x is equal to 2.001, and let's find f of x, and so forth. And let's do that. Let's find the slope for each one of those. So I'm going to do this on my calculator, and then I'll bring it over to show you. So let's go back to the calculator. Open this up. So I'm going to now do f1 of 2.01. Oops, 2.01. And that gives me 20.19301. Now if I go back up and grab this, basically I'm going to use the slope formula, only I'm going to change. This is now 20.11. Actually, I could have copied that. 119.301. And down below, this is now 2.01. So now I see that I have 11.9301. And then I want to try this one more time with 2.001. So I'm going to type in, I'll just go back up and grab this, change this to 001. There is my new number. Now I've got this on a large decimal place float. I'm not sure if I have it on a 12 decimal place float or what I have this on, but maybe more than yours. Yours may be rounding, and if it does round, just make sure you go back and grab the number from the calculator so that you don't get any rounding error when you're calculating. Actually, I'm going to go back down here. I will do the fraction. This might be faster to do it this way. Fraction, I'll go up and grab this number, and this is minus 20 in the numerator. Then in the denominator, I'm going to have 2.001 minus 2. Okay, so notice what's happening with my slope. My slope started out as 11.31, then 11.9301, now 11.993001. And if I did one more time, let's just do one more time. So I'm going to go grab this and put one more 0 in here. Now we have 20.00119993. So using my slope formula, I go up and grab this number, subtract 20 from it. So we're just taking points that are closer and closer. 2.0001 minus 2. Notice we're just picking points that are closer and closer to 2 in the x direction. We're finding the corresponding y value, and we're just finding the slope between those 2 points. And we notice that as we do this, the slope gets closer and closer to 12. Okay? That's what I want you to be noticing. The slope's getting closer and closer to 12. And let's transfer some of this to the notes. And I'm going to just do some copy and pasting on my part, I think. And then we can, I'll give you a moment to pause. Why don't you pause, and I'll pause, and we'll add this to our notes. So I've noticed that my slope appears to be approaching 12. And that's what I want you to notice here. Do I hear the word limit? I think it's going to end up in here somewhere. Okay, I had meant to go further with this video, but I think I'm going to have to stop this segment right now, and then we'll finish, we'll add another segment to finish up this page of notes.